Welcome to solverfy.
The answer to this question is obvious if you've ever seen a piece of wood in water. But let's do a thought experiment. Now, let's say our container is full of water. I'm sorry, full of some fluid whose density is greater than the density of an object. Now, as the object is lowered into the water, the buoyant force on it increases. The weight of the object is obviously mg, which is volume times g times its density. Let's call it rho object. And the buoyant force is obviously volume submerged times g times density of the fluid. So obviously the density of fluid is larger than density of object, which means when these two are equal, the submerged volume will be smaller than the total volume. Well, let's write it again. The submerged volume, small v, times rho of the fluid is equal to the total volume times rho of the object. Submerged volume by total volume is rho of the object by rho of the fluid. Because the fluid has a larger density, this will be less than 1, which means the buoyant force will be equal to the weight before the object fully submerges. Let's say around this point, the buoyant force and the weight will be equal and they cancel out. So the object will simply stay there. It won't go down or up. This is floating basically. When an object which has density smaller than that of a fluid